Chemical processes involve changes with electrons. Nuclear processes, which we're interested in these lessons, involve changes in atomic nuclei. Spontaneously changing nuclei emit radiation and are said to be radioactive. When we say radiation, we're talking energy and/or particles that are emitted from the nucleus. Nucleons are protons and neutrons. Any particle that's in the nucleus is a nucleon. Protons and neutrons collectively we call nucleons. Therefore, in the atom, there are the nucleons right there. I'm going to blow them up so you can look at them a little bit more closely. The mass number, you should remember, is the sum of the protons plus the neutrons in a given atom. So the mass number is the number of nucleons in an atom. Isotopes, you should remember also, are atoms that have the same number of protons but different numbers of neutrons. Radioactive ones are called radioisotopes. All isotopes of an element behave the same chemically. Your body uses a lot of carbon. Most carbon is carbon-12, which is not radioactive. But some carbon, carbon-14, is radioactive, and your body treats carbon-14 no differently than it treats carbon-12. Doesn't even notice, you might say, that it's a radioactive carbon atom instead of a stable one. A nuclide is a nucleus with a specified number of protons and neutrons. Radioactive ones are called radionuclides. Radioisotopes and radionuclides are unstable, and they emit radiation. And finally, the atomic number is symbolized by capital Z, and it is the number of protons. The way I remember that is the number of protons has the final say in terms of what type of atom it is. Final say, number of protons, this is the type of atom it is, that's it. And Z is the final letter in our alphabet. That's how I remember that the number of protons is sometimes symbolized by the capital Z. Radioisotope, or radionuclides, have too many or too few neutrons. If you have the, we might say, Goldilocks number of neutrons in a particular atom, that's a stable atom. If you have too many neutrons or not enough neutrons, that atom is going to be restless and radioactive. And in that case, the nucleus attempts to attain a lower energy state by releasing the extra energy as radiation. For example, alpha, beta particles, gamma rays. In radioactive decay, these things are spit out of the nucleus. They emerge from the nucleus in the nucleus attempting to attain a lower energy state. Let's summarize Introduction to Nuclear Chemistry. In nuclear chemistry, we focus not on the electrons, but instead on the nucleus and how it changes. Radioisotopes are radioactive atoms. Radionuclides are radioactive nuclei. A nucleus is radioactive, that is, it emits radiation as either energy or particles, when the ratio of its number of protons to neutrons isn't right.